Assalamu alaikum and welcome. Good evening. This is video number 406, multiple linear regression in STATA, and this is model 1. And this video is meant for intermediate level user. It's a little bit advanced than those meant for the beginners. In this video lecture, I'm using data set and I'm going to estimate this model. There are two variables. yi is the dependent variable, age is an independent variable, but it is a scale variable or a continuous variable, and health status is also an independent variable, but it is categorical variable. And finally, this is the error term. Now, health status has 5 categories. It starts from excellent health status, very good, good, fair, and poor. In this file there are 10,351 observations, so it's quite a big sample. I will be discussing these results, but let me first go to my STATA file. I have already uploaded this file. So first of all, I will describe the variables. So there are a large number of variables, and actually there are 42 variables in this model, in this sample, sorry. And I'll be using age as my independent variable. I'll be using BP systole, that is systolic blood pressure, as my dependent variable, and I'll be using health status here. Health status, this is my independent categorical variable, and I may also use BMI as an independent variable. So let me start with the simple linear regression model. So I will write rec, and then here is my dependent variable, and after this I will give BMI. BMI is my independent variable. So here is BMI. So if I enter, so I get this estimated model. This is analysis of variance. This is f stat, r squared, adjusted r squared, root mean square error, and this is the coefficient for BMI. Its standard error t value and its p value. This is 95% confidence interval, and this is the constant of the model. This is its standard error, this is its t value and its p value and its confidence interval. After this, I will run another model in which I will regress BP systolic blood pressure on age and health status, HLT. I can also give this from here, it's already available here, but I will have to specify this. I will have to write small I dot in front of this variable, and this is, I'm telling STATA to treat this variable as a categorical variable. If I don't write I dot in front of this variable, then STATA will treat this variable as a continuous variable. So here is the command rec BP systole, that is systolic blood pressure, regressed on age, and health categorical variable. Again, this is ANOVA, and these are some other information. Number of observation 10,335, and this is f stat, this is r squared, this is adjusted r square, root mean square error, this is coefficient for age, so it has positive correlation, and this is significant. And then this is the health state. Since this is categorical variable and there are 5 categories of health state, so excellent health state is taken as a base category, and very good, good, fair and poor have been estimated here, and these are their coefficients. Standard errors for these coefficients, and t-values for these coefficients, and p-values, as well as 95% confidence interval, and this is the constant or intercept of the model. So three of the t-values or three of the coefficients for health state are significant. They are significantly different from 0, and this very good one is not significant because its p-value is 0.117. It's greater than 0.5. I can do one thing. I can test a null hypothesis that whether these four coefficients are jointly equal to 0 or different from 0. So my command will be test parm, and I will write health state, test parm, and I health state. So here is my test. This is f test, and its f test value is 15.14, and this is its p value, which is 0.000. So these are the null hypotheses, and this means that very good, fair, and poor health, these coefficients are equal to 0. But this is significant, so we reject this null hypothesis, and we conclude that at least one of them is significantly different from 0. But we can notice here that three of them are actually different from 0. I can also use another method, and in which I will use the interaction coefficient. So if I do this, so the command is regress bp systol I dot health state, and then these two, and c dot h. Now this number science, it basically tells the STATA to estimate such a model that it gives main effect of age, main effect of health state in one model, and then their interaction. So we can see this is the main effect of health state, and this is the main effect of age, and here these are the coefficients of interaction between health state and age. You can see it here. So again, I can test this hypothesis whether these coefficients are different from 0 or not. So again, test parm in this model I health STAT. Now this time, since these t values are different from 0 and p values are greater than 0.05, now this time the f state is not significant, so we fail to reject the null hypothesis, and these coefficients are jointly not different from 0. We can also test this hypothesis whether these coefficients for the interaction of health state and age, are they jointly equal to 0 or different from 0. So again, I'll test parm, and I'll write I health state, and then this, and c age. Now here c age means that age is a continuous variable. So here this value says there are 9 coefficients here, and it says that this is for health, and this is for age, and these 4 are for the 4 coefficients. Now this f test is different. This is less than 0.05, so this value is significant, and it means that all these coefficients are jointly different from 0. So this is a brief introduction to multiple linear regression model, and in this particular model I used two variables, two independent variables. One was age, that is continuous variable, and the other one was health. Health is a categorical variable. Now I am using another regression, and in which I will regress BPC stall on two continuous variable BMI, and I can also use one categorical variable. Now this model, there are two continuous variable, and both of these coefficients for age and BMI are significant, and these for health state, three of the coefficients are different. They are less than 0.05, and one coefficient for the very good health state is non-significant, and for the intercept this is significant. So this is also multiple linear regression model in which there are three variables, three independent variables. Two are continuous and one is categorical variable, and its f state is 760 and it's significant. R squared is about 31. It means 31% of the variation in systolic blood pressure is explained by these three variables, that is age, BMI, body mass index, and the health state categories. I hope you like this, and if you like, you can share this with your friends, with your colleagues. If you have still any question, you may ask me in the comments below. So you can also check these results for yourself. This is the do file, and this is a detailed do file. You can play with other variables in this model. If you haven't yet subscribed, kindly subscribe to the channel, and do not forget to click on bell icon. Kindly share this video and channel with your friends, with your colleague, and with your friends and students, and share it in various WhatsApp groups so that it can reach to maximum possible number of people. Thank you, and see you in another video.